Find two values of theta between 0 to 360 that satisfy the following equations. Keep in mind that the sine of theta is equivalent to 1 divided by the cosecant. The cosine of theta is equal to 1 divided by the secant. And finally, the tangent of theta is equal to 1 divided by the cotangent. So really, in these next 6 examples, we're going to take everything that we have learned about the unit circle and we're going to apply it. Let's get started. Please know that these are considered primary trig functions, and we're going to call these secondary trig functions. So when I see that the cosecant of an angle is a positive value, that tells me that its reciprocal, sine, is also a positive value. Where are sine values positive? All-star trig class. Sine values are positive in quadrants 1 and quadrants 2. So I'm going to start by coming over here and highlighting quadrants 1 and 2. Here we can see that the cosecant is negative. That means its reciprocal, sine, is also negative. Sine values are negative in quadrants 3 and quadrants 4. The secant value is negative. Secant is the reciprocal of cosine. That means cosines must also be negative. Cosines are negative in quadrants 2 and in quadrants 3. Here the secant value is positive, meaning that the cosine value would also be positive. 2 more remaining. The cotangent is negative. If the cotangent has a negative value, that means the tangent would also be negative. Tangents are negative in quadrants 2 and 4. And here the cotangent is positive, and I can find tangent values positive in 1 and 3. All right, next up, I'm going to rewrite this as the sine of this angle is equal to 1 divided by 4.8097. These are equivalent statements. I can do this because I know that the cosecant and sine are simply reciprocals. So here's 4.8097 divided by 1, and then when I take the reciprocal of it, of this value divided by 1, and now 1 divided by the value, I know that's equal to the reciprocal of cosine, which is sine. Whenever we're trying to identify an angle, we can use that arc, in this case, arc sine or inverse sine. So you can write down arc sine of the angle equals 1 divided by 4.8097, or maybe you're going to write the inverse sine. They're equivalent mathematical statements. Grabbing the calculator, make sure that you're within degrees. I am within degrees, and now I'm going to type in second sine to get the inverse sine of 1 divided by 4.8097. So I come up with 12. Similar to the last video, we're going to go 12 up on the right, and in this case 12 up on the left. So my reference angle is 12, and now I'm going to identify those two angles. So I believe 12 degrees is 1, and when I take 180 and subtract 12 degrees, I'm at 168. Is there a way that I can make sure this works? Well, let's check. I know that these two statements are equivalent. Let's check. Sine of 12 degrees, okay, and sine of 168. Now let's check and see, is this measurement equivalent to this? 1 divided by 4.8097 is equivalent to this. I feel confident these two are correct. I would like you to try the second example. Press pause on the video, go ahead and complete it, and then come back to the video when you are done. All right, hopefully you're back with me. I'm going to start by rewriting this as, one second. Oh no, piggy bank just fell. So this is equivalent to the sine of this angle is 1 divided by negative 1.1033. Why? Because I know these two are reciprocals of each other. So the reciprocal of this value over 1 is 1 over its value. Okay, next up what I'm going to do is I'm going to use the idea of arc sine, or maybe you like the inverse sine, depending on which one you like to use. and I'm going to plug this into the calculator. So it's not necessary for you to write it in both ways. I just want you to see that there are two ways to represent the exact same mathematical statement. Okay, inverse sine, I know that I'm within degrees of 1 divided by negative 1.1030, and I get negative 65. Where do I find a negative 65? That means from this point, we're going to drop down 65. I'm going to drop down 65. So I'm going to grab my calculator, and from 360, I'm going to drop down 65, and I end up with 295. Now, I've already located the two quadrants where I'm going to find this. So I'm going to use that reference angle of 65 degrees to drop down 65 on the left-hand side. So 180 plus an additional 65, 180 plus an additional 65 is 245. I believe that the two angles would be 295 and 245. Is there a way I can check this? Absolutely. Let's go ahead and check. The sine of 245, the sine of 295, we can take it the exact same measurement. And now let's go ahead and just check to see, is this value equivalent to these decimal marks? 1 divided by negative 1.1030. We can see it's exactly the same. I feel confident in my answers. Let me demonstrate how to do the third example using secant. I'm going to rewrite this as the cosine of the angle is 1 divided by negative 1.5557. And now whether I use arc cosine or inverse cosine, it's up to you. Whenever we are trying to find that measurement, we're going to use this inverse value. Grabbing my calculator here, inverse cosine or arc cosine of 1 divided by negative 1.5557, and I come up with an angle of 130. An angle of 130. Where do I find 130? Well, here's 90, here's 120, so it's approximately right here. Now let's identify the reference angle. Let's identify the reference angle. I didn't color this very well. It's down there more. So the reference angle is, what is the distance back to the x-axis? That's always a reference angle, whether you're going up or down. What's the quickest way back to the x-axis? So I know that this is 180. So here's a reference angle of 50. So if I drop down 50, 180 plus 50 would be 230. I believe the two numbers would be 230 and 130. That's what I believe the two values should be. Is there a way to check? Yes, there is. Let's go ahead and try this. The cosine of 230 better be equal to the cosine of 130. And we can see they do equal each other. Now, if I simply plug this in, 1 divided by negative 5557, I also get that same value. These are the correct answers. Just like we did with example number 2, for example 4, I'd like you to press pause on the video, complete it, and then come back to the video. Let's go ahead and write this as the cosine of this angle is 1 divided by 1.0641. Again, whether you write arc cosine or you do the inverse cosine, we should be getting the exact same mathematical answer. Second cosine of 1 divided by 1.0641. Okay, so approximately 20. It's in approximately 20 degrees we can see. So I'm going to go up 20 degrees. I'm also going to drop down 20 degrees. That's my reference angle. So I'm going to check 20 and 360 minus 20 is going to be 340. Let's see if those are correct. Cosine of 20 and cosine of 340. Okay, now if it's correct, this value will also equal this decimal amount, 1 divided by 1.0641, and it does. I feel confident in these two answers. Let's go on to our final two examples using cotangent. It's going to work the exact same way. Let me demonstrate how to do number 5 for you. So I'm going to write this as the tangent of theta equals 1 divided by negative 1.1917. And again, whether you write arc tangent or inverse tangent, it's up to you and your preference. So inverse tangent of 1 divided by negative 1.1917. So approximately negative 40. So I'm dropping down here 40 degrees, dropping down 40 degrees. So 360 subtract 40 would be 320. So I believe 320, and then I'm going to jump up 40 degrees. 180 subtract 40 is 140. I believe these are the two angle measurements between 0 to 360, but let's test it. Tangent of 140 and tangent of 320. We get the exact same mark, and that value should be equivalent to 1 divided by negative 1.1917, all equal. The final example in this video, please go ahead and do example number 6 and then come back. We have the tangent of theta is equal to 1 divided by 0.1763. And I'm going to write down arc tangent, but you could do inverse tangent, all up to your preference. Grabbing a calculator, second tangent of 1 divided by 0.1763 gives us an angle of 80 degrees. So up here, I'm going to go up to 80 degrees. That's my reference angle. And then from the x-axis, I'm going to drop down 80 degrees. So we're going to drop down 80 degrees. If I'm at 180 and I add an additional 80 to it, I would be at 240. So right here, this terminal angle is 260. So I'm checking 260 and 80. I believe they're going to give me the exact same values. Let's go ahead and try this. Tangent of 80, tangent of 260, we can see they are the same. And if I take 1 divided by 0.1763, we get the exact same thing.